matriculants. My name is Mike Ngwabi, and today we'll be doing the review of the November 2011 paper 1. Okay, without wasting time, let us get started with question 1.1.1, which says, solve for x. And the question is, x times x plus 1 is equal to 6. Okay, the method to follow here first would be to open up your brackets. So you multiply in x times x is x squared plus 1 times x, which is x, which will equal 6. Then as you see, we've got the form of a quadratic equation. Then you need to bring the 6 over so that you complete the quadratic equation. The moment you're here, you're now stuck with two methods. You could either use your two brackets or you could use your quadratic formula. Let us start off by using the quadratic formula. It's minus b plus or minus the root of b squared minus 4ac all over 2a. Okay, so a, b, and c, a will be 1, b will be 1, and c will be negative 6. So we just substitute for those coefficients. It become negative 1 plus or minus 1 squared minus 4 times 1 times negative 6 all over 2 times a, which is 2 times 1. Then from here we'll pretty much simplify it. Feel free to plug this straight into your calculator if need be, or you can solve it manually if you want. This will become plus or minus 1 squared minus 4 times 1 times negative 6 will be positive 25 all over 2. Then this becomes plus or minus, the root of 25 is 5 all over 2. So therefore, since it's plus or minus, we have to get two solutions for this. So the one will be plus 5 over 2 or negative 1 minus 5 over 2. Okay, so moving on from here, negative 1 plus 5, that becomes positive 4. 4 over 2 is 2. So our two solutions are 2 or negative 1 minus 5, which is negative 6 over 2, which is negative 3. Okay, so that's our first method. Let's take a look at another method which some students prefer. Okay, so method 2, our equation is x squared plus x minus 6 is equal to 0. You create your two brackets and then you put your x and x. Then you think of two numbers that multiply to give negative 6 and at the same time add to give the coefficient of x, which is 1. So you think of the multiples of 6. There is 6 and 1. There's also 3 and 2. If you think about it, only 3 and 2 give you 1. Because we say 3 minus 2, you get 1. Right? And 3 times negative 2 gives you negative 6. So those two are plus 3 and negative 2. So now, eventually to solve for this, as we all know, your one solution will be x plus 3 is equal to 0, and x would therefore equal negative 3. Or, the second bracket, x minus 2, will equal 0, and therefore x will equal 2. And then those will be your two answers. Okay, this might be a quicker method. If you prefer the first one, that's also a safe method to use. Okay. That's question 1.1.1 done. Let's move on to the second one, to question 1.1.2. It's also solve for x, and the equation there is 3x squared minus 4x is equal to 8. Once again, this is the form of a quadratic equation. Let's bring the 8 over. It becomes 3x squared minus 4x minus 8 is equal to 0. Okay, then looking at this, it'll be hard to actually try to find the two numbers as we did with the previous question and try to get two brackets. Rather, let's use the quadratic formula. It'll be more accurate and more useful for us. Okay, in this instance, a will be 3, b will be negative 4, and c will be negative 8. And we're using the same formula all over 2a. Then substituting our variables, it should be minus, then b is negative 4, plus or minus negative 4 all squared minus 4 times 3 times negative 8 all over 2 times 3. Then once again, you could either use your calculator, it will be more straightforward if you do so, or you could do it manually. This becomes 4 plus or minus 16, because negative 4 squared is 16. 4 times 3 is 12, and then 12 times 8 should give us, if not mistaken, 96. Okay, all over 6. And then all in all, eventually, you should have 2 plus or minus 2 the root of 7 all over 3. And then your two solutions, one will be the positive, the other will be the negative, should be 2,43 or negative 1.10. And that will be the end of question 1.1.2. Now we're moving on to question 1.1.3, which also says solve for x, and this time around it's an inequality. It's greater than or equal to 5x. Okay, the method to follow here now is to once again put everything on one side, have your quadratic equation, and then solve for that quadratic, and then the methods that you should all know by now. I would choose the table method to solve for this. Okay, so this becomes 4x squared plus 1 minus 5x is greater than or equal to 0. If I rewrite this, it becomes 4x squared minus 5x plus 1 is greater than or equal to 0. Then we'll have your two brackets. Looking at this, through intuition, I'm trying to find the two numbers which multiply to give 4, but at the same time add up to give negative 5. All in all, we'll boil down to this formula. It should be 4x minus 1, and I'd say x should be x minus 1 as well. Okay, then from here, you've got your two solutions. The method to follow here is to get your smallest number and your biggest number. Then you test along the whole number line. By that I mean your two solutions should be 4x minus 1 is equal to 0, which is 4x is equal to 1. Therefore, x will equal to 1 over 4. That's your one solution. Or x minus 1 will equal 0, therefore x is equal to 1. Okay, just turning over, our two solutions are 1 over 4 and 1. We're going to use this as our guide to test for our two inequalities which one will be greater than or equal to 0, which means which one is positive. So we have x is equal to 1 over 4 or x is equal to 1. The smallest number here we have is 1 over 4. So you test for x's less than or equal to 1 over 4. Then you test between 1 over 4 and 1. In other words, between 1 and 1 over 4. And lastly, you test for x's greater than or equal to 1. As I said, we're using the table method. And our two brackets were 4x minus 1 and x minus 1. Okay, a number which is less than or equal to 1 over 4 could be 0, right? So if you plug in 0 there, you should get a negative answer. 0 again in here, you get negative. Therefore, negative times negative, since we're multiplying those two brackets, should give you a positive. Then a number between a quarter and 1, let's take half for example. If you put half in there, it becomes 4 times a half, which is 2. 2 minus 1 is 1, and that's positive. Put half in here, half minus 1 is negative a half. That's negative. Positive times negative is negative. Then finally, let's test for a number which is greater than 1. Let's take 2. 4 times 2, 8, minus 1, 7 is positive. 2 again, 2 minus 1, that would be positive. Okay, what was our criteria? Our criteria was 4x minus 1 times x minus 1 should be greater than or equal to 0. That means we need solutions which are positive. because greater than or equal to 0 means a positive number. Only these two give that solution, because that's the negative one. We don't want this one. So our two solutions will alternately be those two. So it will become x is less than or equal to 1 over 4, or x is greater than or equal to 1. And that will be the end of question 1.1.3. Any questions from the students?
So like, is it necessary to draw the table during the exam?
Yes, this is the one method to use. It's a specific method. It's called the table method. So you could use it, like if you prefer to use this method, but it's also presentable to have it in that format. Moving on to question 1.2. The question says, consider the equation x squared plus 5xy plus 6y squared is equal to 0. And then question 1.2.1, calculate the values of the ratio x over y. Okay. So we're working with x squared plus 5xy plus 6y squared is equal to 0. Then they want us to find the ratio of x over y. So most of you might ask, okay, where do I even start with this question? Okay, simply, you can see there is no x over y yet, but there's nothing stopping you from creating an x over y. You can simply create an x over y by dividing through each thing by y squared. Okay, so that term you divide by y squared, that term you divide by y squared, and that term you divide by y squared. Why are we doing that? We're trying to bring the y underneath the x, because they're working with x over y. So, by that I mean, if we've got x squared plus 5xy plus 6y squared is equal to 0, let us divide by y squared, and y squared. Okay, then eventually this will be x squared, y squared, which you can write as x over y all squared. Okay, why are we doing this? Because we are trying to deliberately get x over y into the equation. Then we say plus, there's that y and that y. Using your laws of indices, we know that these somehow should eliminate. Or you could bring the y on top, depending on how you want to do it. But then let's simply do this. That y is to the power 1. Okay, this should cancel with that square. In other words, you'll be left with 5x over y. Then lastly, this y squared and that y squared, they cancel. And you're left with 6. So all in all, can you see you're left with x over y all squared plus 5 times x over y plus 6 is equal to 0. Okay, so we've actually, can you see, we've got our x over y in place now. Can you see this has the form of a quadratic once again? Because you've got a square there, you've got an x over y, you've got your 6. Let us say, let k equal x over y. This becomes k squared plus 5k plus 6 is equal to 0. Okay, can you see this is easier to solve now that we've just done that substitution. We do this in order for us to solve for k first, then eventually we will know what x over y is. Okay, so moving on from there, let us solve for this. It will be 2 brackets, k and k, then the two numbers that are multiples of 6 that also add to give 5 are 3 and 2. So it will be k plus 3 and k plus 2. Okay, so those are the solutions for k. In other words, k will equal -3 or -2. And what did we say k is? It's x over y. So it's the same as saying x over y is equal to -3 or -2. And those will be your two ratio values for x over y. Okay, moving on to question 1.2.2. It says, hence calculate the values of x and y if x plus y is equal to 8. Okay, so whenever in a question they say hence, they mean use what you got in the previous question. Okay, so we got x over y is equal to negative 3, which is the same as x is equal to minus 3y. Okay, in other words, I'm just trying to get what x is in terms of y. Or we got x over y is equal to negative 2, which is x is equal to negative 2y. Why am I doing that? Because I'm trying to calculate the actual values of x and y. They give us an equation, x plus y is equal to 8. We're going to use this in conjunction with what we got from the previous questions, and that x is equal to minus 3y or x is equal to minus 2y. We use the method of substitution. Substitute where x is minus 3y. This becomes minus 3y plus y is equal to negative 8. This becomes minus 3y plus y is minus 2y is equal to 8. Therefore, y will equal, if you divide both sides by negative 2, this will become negative 4. That's your one solution. That's for y. So if y is equal to negative 4, what will x equal? When y is negative 4, we can simply use this equation. X will equal 8 minus y, which is 8 minus y is negative 4, which is 8 plus 4. Gives you 12. So when y is negative 4, x is equal to 12. We do the same thing. This will become x plus y is equal to 8. We substitute negative 2y for x. It becomes negative 2y plus y is equal to 8. Negative 2y plus y becomes negative 1y. Therefore, y will equal negative 8. Okay. Now that you've got y is equal to negative 8, do the same thing. You want to calculate what value of x will equal negative 8. Substitute back in here. That will become x is equal to 8 minus y. So it becomes minus 8, which is 16. So your two solutions will be when y is negative 4, x is equal to 12. When y is negative 8, x is equal to 16. And that's the end of question 1.2. Anyone have questions?
So like this is the same as when you're solving for x and y simultaneously.
Simultaneously. That's pretty much the same method. Okay.
What I didn't get is how do you get x is equal to negative y, negative 3y? Yeah.
Negative 3y.
Yeah.
Okay. So from the previous question, we got x over y is equal to negative 3 and x over y is equal to negative 2. We're trying to do the whole substitution of simultaneous equations per se. So we want to use that method, but for us to use that method, we need variables of x only or variables of y only to use. So they give us a second equation to use. So based on what we have there, we need to try get x to stand alone or y to stand alone. And you do that by multiplying this side by y in order to cancel that y, right? But whatever you do on the left-hand side, you do on the right-hand side. This will become minus 3 times y. So that becomes x is equal to negative 3y. Then that's the same thing we did. That's it. Okay. Okay, so that's question 1 done. Let's move on to question 2. So question 2 says, given the sequence 4x and 32, determine the values of if the sequence is 2.1.1 arithmetic or 2.1.2 geometric. Okay, so let's look at what we have. We're given a sequence there for x and 32. First question is to determine the value of x if the sequence is arithmetic. Okay, what do you know about arithmetic equations? What's the difference between arithmetic equations and geometric equations? One, there's a common difference. The other, there's a common ratio. So we're going to use that knowledge to solve these equations. So what's the common difference there? It's always term 2 minus term 1, right? In other words, term 2 minus term 1 should equal to the common difference of those two, which is term 3 minus term 2. In other words, x minus 4 should equal to 32 minus x. And the reason this is so is because the difference should be the same. It should be common. Okay, so the moment we've got this, as you can see, we've got an arithmetic equation. We just solve it normally now. So we take the numbers over to the one side and the x's over to the other side. This becomes plus x, and this will become plus 4. Then that becomes 2x. 32 plus 4, 36. Therefore, x will equal 18. Okay, so that would be 2.1.1. Then moving on to 2.2.2, 2.1.2 rather. Now it's geometric. What do you know about geometric equations? There's a common ratio. So just like there we say T2 minus T1, if it's geometric, it should be the ratio of T2 over T1 should equal to the ratio of T3 over T2. What's T2? X. Over T1, T1 is 4. T3 is 32, T2 is x. Once again, we're at this point. Now we have an equation. We solve this the normal way we would solve an equation. Let's rather do cross multiplication to bring everything on top. So that goes there, that goes there. So this will become x squared is equal to 32 times 4. Okay. And this in turn should give us 128. Okay. So we got x squared is equal to 128. Therefore, x will equal the root of 128. And that should be the solution for x if that equation is geometric. Okay. Moving on to question 2.2. It says determine the value of p if p is equal to the summation of k starting from 1 up to 13 for the equation 3 to the power k minus 5. Okay. So here we're working with, it's also a sequence, only that they've written it in terms of summation. You should have studied this by now, and you should know the method to go about doing this. Okay, first of all, let's find out what type of sequence it is. Like by substituting first for k is equal to 1, k is equal to 2, k is equal to 3. Let's see what equation we're working with. So if k is equal to 1, we'll have 3 to the 1 minus 5, right? The second term will be 3 to the 2 minus 5. Third term is 3 to the 3 minus 5, and so forth. Okay. Then, if we simplify this, 1 minus 5 is negative 4, 2 minus 5 is negative 3, 3 minus 5 is negative 2. Okay, and so forth. So the next term would most probably be 3 to the negative 1, 3 to the 0, and so forth. But this is enough for us to know what's going on. Would you say we're dealing with a common ratio or a common difference? I would say a ratio. Reason being, let's find out what the ratio of T2 over T1 is. T2 is 3 to the negative 3, T1 is 3 to the negative 4. This is the same as 3 to the negative 3, since it's dividing, it's going to be subtracting, minus the negative 4, which is 3, negative 3 plus 4, which is the same as 3 to the 1. You see that ratio? It's 3. Let's check what the ratio of T3 over T2 is. T3 is 3 to the negative 2, T2 is 3 to the negative 3. This will become 3 to the negative 2 minus 3, which will also be minus 2 plus 3, which is 3 to the 1. So can you see? We're working with a common ratio. In other words, this is a geometric sequence. Okay, and what are they asking us to find? The sum. This stands for the summation of all the terms from 1 up to 13. So we're going to use the formula for summation, but then we're going to use the geometric summation formula. Okay, then working with that, I'm just going to turn over now. We know that our R, which is our common ratio, is 3. And the formula to use for summation is A Rn minus 1 over R minus 1. What's your A? First term. What was our first term? 3 to the negative 4. So this becomes 3 to the negative 4. R is 3. We're trying to get the sum of 13 terms, 1 up to 13. So n is 13 minus 1 over 3 minus 1. From here, that's pretty much it. You just put that into your calculator. So your final answer for that equation should be 9841,49. And that's the summation of your terms from 1 to 13. Okay. Any questions? I know it might be a bit tricky, but I'm sure you followed. Any questions? Okay, so that's the end of question 2.2. Moving on to question 2.3, it reads, prove that for any arithmetic sequence of which the first term is A and the constant difference is D, find that, or rather prove that the sum to n terms can be expressed as like the sum of n terms is equal to n over 2 brackets 2a plus n minus 1d. Okay, so for this question, this is a very typical question they like to ask. They want you to prove that this formula is given by this equation. And there's no other way to do it but to take it as it is given to you in your books. Okay, I know you should have covered this in class by now, and the proof is just simple. Just try and memorize or just follow it according to the way they've taught you in the book. Okay, and that method is you write out what a typical sequence will look like. You're trying to sum them, right? It's the sum of A terms. Let's say, okay, this is question 2.3. Let's say if you've got an arithmetic sequence with first term A, what's your second term? It's A plus the first difference. Your third term is A plus second difference, right? All the way up to A plus n minus 2d plus A plus n minus 1d. Okay, so if I'm just to, there I was showing you the sequence. Let's say now we're trying to add all of them. And just to distinguish the two, let me put brackets for each term. Okay, so this would be your summation of n terms. You start off with your first term as A, second term is A plus the first difference, third term is A plus the second difference, and as you get down to your last term, you get to your general equation, which is Tn is equal to A plus n minus 1d. If you're moving backwards to be A plus n minus 2d. Okay, then here there's a whole space of your other numbers. Okay, then the method to prove this that we always use is you reverse the sequence and you add the two. By that I mean you bring in another sequence and then you start from there. What we're saying is that this equation, just like if you had 1 plus 2 plus 3, it should be the same as 3 plus 2 plus 1, right? So we start from there. The summation of all n terms should be n minus 1 d plus this term, a plus n minus 2 d plus dot 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 plus this row. Then that will be your a plus 2d plus a plus d plus a. Okay. So this is simple enough. I've just reversed the sequence. Then, based on the method we use to prove this, we add these two together. In other words, you add each thing term by term. So what that means is, what's Sn plus Sn? 2Sn. Okay. Then what's A? That's a term, right? And I've put this in brackets to indicate that that's also a term. So what's A plus this bracket? Do you see that? You're just bringing in an A into that bracket. So it becomes 2A. Okay. So that becomes 2A plus n minus 1d. Plus. Now, which two terms are we adding? The second terms. So if you add A plus D to A plus n minus 2d, what should you get? Let's do it this way, just so that you don't get confused. We're saying A plus D plus A plus n minus 2d. Okay, this becomes the A and the A, that's 2A plus D. The D multiplies in, right, and that should be plus nd minus 2d. The d and that negative 2d become negative d, right? Plus nd, or rather 2a plus nd minus d. That you can then rewrite as, can you see that? Can you see you're getting the same thing, 2a plus n minus 1d for the second term. So we just write that there. We'll have 2a plus n minus 1d plus dot 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 plus. Okay. These I just did to show you what we get there. Let's move on to the next two terms, which are a plus n minus 2d and a plus 2d. In other words, let's do the same thing we did. Let's see what we get. It's a plus n minus 2d plus a plus 2d. There's an a there, there's an a there. That's 2a. If we open up brackets, we'll have plus nd minus 2d. Then we've got a plus 2d there. The negative 2d plus the 2d should, or rather we're trying to add the last two, sorry. So we're going to add that to the a plus d, not to the 2d. In other words, you've got your 2a, then we're adding the second last term to the second last term of our second sequence. So the nd minus 2d plus d, this becomes minus d. Then once again, if you check, we'll have 2a plus n minus 1d. Can you see? It's the exact same thing, replicating. So this n will become 2a plus n minus 1d. So in other words, no matter which two pairs you add up, you're always going to get 2a plus n minus 1d. Then eventually how many terms are we dealing with? If it was 5 terms, it would be 5 times 2a plus n minus 1d. If it was 10 terms, it would be 10 times 2a plus negative n minus 1d, right? But then we're dealing with n terms. So this becomes n times 2a plus n minus 1d. And that's 2Sn. Then finally, your last step would be, you're trying to solve for Sn. It would be Sn is equal to n over t is equal to 2a plus n minus 1d. And that's what I'm trying to prove. So just to repeat the steps to you, we first wrote a sequence of us adding term by term. That's your a plus d plus a plus 2d, all the way up to a plus n minus 1d. Then we reversed the sequence, wrote it like that, and then finally we added each term to each other. We started off by adding the first terms of the sequence, then those two, then eventually we just added the last two. All in all, we're trying to show that whatever we add up, the first two or the last two or the middle two, we're still going to get 2a plus n minus 1d. Then, how many of those terms are there? There's n of them. So it's n times that. Then, eventually, Sn should equal, to bring down the 2, it will be your n over 2, 2a plus n minus 1d. And that's your proof of the summation of an arithmetic sequence. There's no other way to know this, but just to go about it using this one. Okay, any questions? No questions. Okay, now we're moving on to question 3. It reads, the following sequence is a combination of an arithmetic and a geometric sequence. 3, 3, 9, 6, 15, 12. The key word there is, it's a combination of an arithmetic and geometric sequence. So let's see what they're talking about there. So the sequence we're given is 3, 3, 9, 6, 15, and 12. The method behind this is to dissect the two sequences. So let's take the one sequence as 3, 9, and 15. In other words, I'm taking the odd numbers. Then I'm going to take the other sequence as a sequence of the even numbers. So the one sequence is 3, 9, and 15. The second sequence is 3, 6, and 12. Okay, let me call them 1 and 2. So now they've told us already that one of them is arithmetic, the other is geometric. So let's find out which one is which. Okay, you see here, there's a common difference of 6. It's increasing by 6. So therefore, this is your arithmetic. And then, this has to be a geometric now. So the ratio of 6 over 3 is 2. So that would be your geometric. Okay, perfect. So now we know what our sequences are. So they want us to get the next two terms. So that's simply finding the next term for the arithmetic and also finding the next term for the geometric. So simply, this is going to be 15 plus 6, which is 21. So your answers should be 21, and your next sequence is, we're multiplying this by 2. So 12 times 2 is 24. So those should be your next terms in your sequence. Okay. I'm sure there are no questions there. Okay, moving on quickly to the next question. It says, calculate 1052 minus 1051. Already we've seen that our even numbered sequence is an arithmetic. Okay, so 52 is your, okay, this is your odd number sequence. Your odd number sequence is arithmetic. 52 would be your geometric because that's your even numbers. And 51 would be your arithmetic because that's your odd numbers. So, and here can you see we've halved the sequence. There were 6 terms there. Here we're working with 3 and 3. So in other words, for working with 52, we're going to work with 52 divided by 2. In other words, 26 terms of both your arithmetic and geometric. So using that knowledge, we can start tackling the question. Okay, so your even numbered sequence would be your to be a geometric sequence. And that formula for a geometric sequence is Tn. The general formula for a geometric sequence is A times R to the n minus 1. And then we're working with how many? We say we're working with 26 terms. So this will become T26 will equal, from our geometric sequence, we know that A, our first term is 3. We know that our ratio is 2. And n is 26 minus 1. This becomes 3 times 2 to the 25. If you check that in your calculators, it should give you Okay, one of you give me the answer.
It's 1,
0, 0,
yeah, 6,
6, 6,
3, 2,
3, 2,
9,
9, 6.
Yeah.
Okay, perfect. So that's your T26 for your geometric part. And that geometric part, as we say, would be your even numbered question. So that's your T52, in other words. So this will equal T52. Now let's try get T51. Okay, so turning over, we already know that our odd numbered question is arithmetic. Once again, we're going to work with 26 terms. Okay, because we're working with 26 for both, since it's half. It's 26 for both arithmetic and geometric. Okay, so turning over, first of all, our common difference is 6. Our first term is 3. Okay, so we know the general formula for an arithmetic sequence is a plus n minus 1d. We're trying to get T26. We know our a is 3. We know our n is 26 minus 1, and our common difference is 6. Then this should give you 3 plus 25 times 6. If you put that in your calculator, what answer do you get? 153. Perfect. So, and this is our T51. Then the last thing to do is simply subtract your T52 from your, subtract your T51 from your T52. And what answer do you get if you do that? Someone confirm it with me?
100 6
6
314.
3143. Okay. Perfect. So that's your answer for question 3.2. Any questions to the method used?
Just one question.
Yeah.
Why do you have to say 26 on the term like 252? Why do you say 26 instead?
Okay. We'll take it back to what they've mentioned in the question. They've said that the sequence they give us is a mixture of both arithmetic and geometric, of an arithmetic sequence and a geometric sequence. So what that means is they've split them in two, just like you see we did for the first part. We split the two evenly. The one had 3, the other had 3, but initially there were 6. So now we're dealing with 52 terms. Once again, we need to separate between arithmetic and geometric. So you halve the 52, and that's where we get the 26. So we calculate the first 26 terms of the arithmetic part, then the 26 terms of the geometric part. Then that's what we use, that's the knowledge we use to solve the question. Make sense, yeah? Okay. More questions? Okay, so that's question 3.2 done. Question 3.3 says, prove that all the terms of this infinite sequence will be divisible by 3. That should be easy enough. If you use your knowledge of, like, anything which is divisible by 3 needs to have a 3 inside. Let's first look at this term. Can you see it's 3 times that? The general formula is, for the geometric part, is Tn is equal to 3 times 2 to the n minus 1. Can you see there's a 3 there? The 3 will not go away. It will always multiply. So this is exactly what they say, divisible by 3. So that means the geometric part is divisible by 3. Now let's check if the arithmetic part is divisible by 3. We'll go back to the part where we got our equation for the arithmetic. It was that. The general formula for the arithmetic is Tn is equal to 3 plus n minus 1, and what's your d? It's 6. This you can combine. Rather, let's open up the brackets. 6 times n is 6n, minus 1 times 6 is minus 6. This becomes 6n, 3 minus 6 is minus 3. Can you see once again, there's a common 3. If you take out a 3, you'll be left with 2n minus 1. The presence of that 3 means this is also divisible by 3. So now you've proven that both arithmetic and geometric are divisible by 3. Therefore, the infinite series should be divisible by 3 as well. Okay, so in conclusion, your final answer, you would say, since both the arithmetic and geometric sequences are divisible by 3, therefore, the infinite series or the infinite sequence, okay, the infinite sequence would also be divisible by 3. Okay.